Hello everyone, welcome to my new data structures and algorithms in Java tutorial series video. In this tutorial we will discuss an interview coding problem, search in a row and column wise sorted matrix. So friends, in an interview we are given a problem that given a row and column wise n cross n sorted matrix, write a program to search a key in a given matrix. So what do we mean by row and column wise sorted matrix? So here you can see we are given a 4 cross 4 matrix. So by 4 cross 4 matrix we mean that it has 4 rows and 4 columns. And here you can see that each row is sorted and each column is sorted. So for an example, the row at 0th index, you can see the values as 10, 20, 30, 40. And the last row, we have values as 32, 33, 39, 51. And all these rows are sorted in ascending order. And similarly, if you see the columns, then those are also sorted. So for example, 0th index column has value as 10, 15, 27, 32. And similarly, if you take second index column, the values are 30, 35, 37, 39. So this is a matrix in which each row is sorted and each column is sorted in ascending order. And we are given a value and we need to write a program to search that value inside this matrix. So friend, let's suppose we are given this 4 cross 4 matrix which is sorted row wise and column wise. So here as the matrix is 4 cross 4, the value of n is 4, and let's suppose we want to search for a key as 32. Now this key is present into the matrix and we want to write a program which could search this key into this sorted matrix. So friends, here you can see the algorithm for it. Now let's see the working of this algorithm step by step. Friends, there is an inefficient solution, that is using two for loops. And what we do is we compare 32 with each and every value of this matrix and see whether the element is present in the matrix or not. So friends, this is an inefficient approach because the time complexity of this solution is O of n square. And here as we are given this matrix is sorted row wise and column wise, we can use that property to write an efficient code. So let's see a demo of this algorithm. So here we are simply calling this search method by passing in the 4 cross 4 matrix, the value of n and the key which we want to search. So friends, here we know that this matrix is sorted row wise and column wise. Therefore we start our searching from the top right corner of the matrix. Let's say we start from 0, 3 having a value of 40. So what we do is we compare 32 with 40 and see that whether 32 is equal to 40 or not. So if it is equal to 40, we simply print that we have found our element at 0, 3. And here as 32 is less than 40. So the idea behind this algorithm is if we go to the left of 40, we will find all the numbers lesser than 40. And if we go below 40, then we will find the numbers greater than 40. So friend, as this is a row wise and column wise sorted matrix, so for each and every element in this matrix, this property holds true that if we go a step left, we get the number lesser than the current number, and if we go one step below, then we'll get a number greater than the current number. So let's suppose if we are at index 2, 1, so value is 29. If we go one step left, we'll get the values lesser than 29, and if we go one step down, we'll get the values greater than 29. And this property is true for each and every value in the matrix. So we'll use this idea and search for the particular key in the matrix. So in step 1, we'll create an integer value I which will be pointing to 0. So this value I will be pointing towards a particular row of a matrix at a particular index. So currently it is referring to 0th index row. Moving ahead. And then we'll create one more integer variable by name j, and we'll assign a value of n minus 1, which is nothing but 4 minus 1. So friends, j will point to the columns index. So friends, we will start our search from the top right corner of the matrix. So therefore, we have initialized I to 0 and j to 3. And we will start our search from the index 0, 3, having a value of 40. So friends, as we want to search for value 32 inside this matrix, we are providing a while loop. And in this while loop, we are providing the boundary conditions of the matrix so that value of I and j do not cross over the matrix boundary. So as I started from value 0, we will iterate it to a value lesser than n. And we are also providing a boundary condition for j that it has started from 3. It should go till index 0. So currently you see I is less than 4 and j is greater than 0. So the condition in while block comes out to be true. So here we have provided an if block, and inside this if block we are checking that value at matrix I comma j is equal to x or not. So value at I comma j, which is nothing but 40, we are checking whether it's equal to 32 or not. So the condition in if block comes out to be false. And then we are again providing an if block, and we are simply checking that whether value at I comma j is greater than x or not. So here you can see 40 is greater than 32. Therefore the condition in if block comes out to be true. So friends, as this matrix is sorted row wise and column wise, so friends, when we compare 40 with 32, we know that 40 is greater than 32. Therefore we also know that 32 must be lying one step left to 40. So we are simply decrementing the value of j. So it would become something like this. The value of j becomes 2. Moving ahead. Then we are again checking that whether I is less than n and j is greater than equal to 0 or not. So here you can see I is less than n because the value of I is 0. So it is less than 4. And j is greater than equal to 0 because value of j is 2 and 2 is greater than 0. So the condition in while block comes out to be true. We will again compare the value at I comma j index with x. So here you can see the value at 0, 2 is 30. So we'll simply compare the value of 30 with 32. So the matrix value at 0, 2, which is 30, is not equal to 32. Therefore the condition in if block comes out to be false. And then we'll simply check that whether value at I comma j is greater than x or not. So here you can see the value at I comma j is less than x because 30 is less than 32. Therefore the condition in if block comes out to be false, and else part will be executed. So friends, 32 is greater than 30. Therefore it must be lying somewhere below 30. So we simply increment I by 1 to go one step down. So value of I is 0. So now it will become 1. Moving ahead. We again check whether I is less than n and j is greater than 0 or not. So I is holding value 1 and it is less than 4, and j is holding value 2 which is greater than 0. Therefore condition in while block comes out to be true. In the first if block we check whether the value at matrix I comma j is equal to x or not. So here the value at I comma j, which is nothing but 35, is not equal to x, which is 32. Therefore the condition in if block comes out to be false. We then check that whether value at matrix I comma j is greater than x or not. So here you can see the value at I comma j, which is 35, is greater than 32. Therefore the condition in if block comes out to be true. and as 35 is greater than 32, we know that 32 must be lying somewhere to the left of 35. Therefore, we simply go one step left to 35, which is nothing but decrementing the j by 1. So it would look something like this, that value of j becomes 1. Moving ahead. Now again we'll check in the while loop that whether value of I is less than n and j is greater than or equal to 0 or not. So here you can see the value of I, which is 1, is less than 4, and value of j, which is 1, is greater than 0. Therefore the condition in while block comes out to be true. We again check in the if block that whether value at I comma j is equal to x or not. So here you can see value at I comma j, which is 25. So 25 is not equal to 32. Therefore the condition in if block comes out to be false. And then we'll again check that whether the value at I comma j is greater than x or not. So currently 25 is not greater than x. So the condition in if block comes out to be false, and else part will be executed. So friends, as 32 is greater than 25, we know that this value might lie somewhere below 25. So we'll simply move one step down by incrementing the value of I. So I becomes 2. Moving ahead. We'll again check whether I is less than n and j is greater than equal to 0 or not. So here you can see 2 is less than 4 and 1 is greater than 0. Therefore the condition in while block comes out to be true. We check the value of matrix at I comma j is equal to x or not. So here you can see the value at I comma j, which is nothing but 29, is not equal to 32. Therefore the condition in if block comes out to be false. And then we simply check that whether value at matrix I comma j is greater than x or not. So here you can see value at I comma j, which is 29, is less than x, which is 32. Therefore the condition in if block comes out to be false, and else part will be executed. So friends, we'll go one step down because 32 is greater than 29. So here, as this matrix is row and column wise sorted matrix, we know that 32 might lie below 29. So we simply go one step down by incrementing the value of I. So I becomes 3. Moving ahead. In the while loop, we'll again check whether I is less than n or not. So here you can see value of I is 3 and it is less than 4. And we also check whether j is greater than equal to 0 or not. So here you can see j is greater than 0. So the condition in while block comes out to be true. Then in the if block we check that whether value at matrix I comma j is equal to x or not. So the value at I comma j is nothing but 33, and we know that it's not equal to 32. Therefore the condition in if block comes out to be false. Then we simply check that whether value at matrix I comma j is greater than x or not. So here you can see the value at I comma j, which is 33, is greater than 32. Therefore condition in if block comes out to be true. Now as this value 33 is greater than 32, we know that value must be lying to the left of 33. So we simply go one step left by decrementing the value of j. So j becomes 0. And then again in while loop we check whether I is less than n and j is greater than or equal to 0. So here you can see value of I is 3 and it is less than 4, and value of j is 0, which is equal to 0. Therefore condition in while block comes out to be true. Now we simply check that whether value at matrix I comma j is equal to x or not. So here you can see the value of matrix at 3 comma 0, which is 32, is actually equal to 32. Therefore, condition in if block comes out to be true. So friends, here we know that we have found our value. So therefore, we'll simply print on the console that x is found at 3, 0. So in the console, we are simply printing that x is found at 3, 0. And then we'll simply return from this method. So friends, in this tutorial, we saw the demonstration of the algorithm. Now let's go to Eclipse and see the working of this code.